Hi, this is Fritz Onion with Pluralsight, and I'll be presenting this module on ASP.NET Architecture. What we're going to be focusing on in this module is a look at how ASP.NET fundamentally works. So we'll start off with a discussion of the architecture of ASP.NET, what happens when a request comes in for an ASPX file, and how is that serviced and how is it handled with respect to IIS. We'll talk about how ASP.NET integrates into IIS, both in IIS 6 and 7, as they differ somewhat, as well as the worker process and the ISAPI integration. Then we're going to step back and take a look at sort of the evolution of ASP.NET. How has it evolved over time, and where is it today? So we'll look at some things like dynamic content, its history in classic ASP, as well as the newer server-side controls and data binding and declarative data binding models. So hopefully give you a sense for how pages are typically developed in ASP.NET and the sort of fundamental techniques for presenting dynamic content. We'll also take a look at the code behind model. How do you specify a class that's going to be used in association with your page? We'll take a look at the page lifecycle, the sequence of events that occur every time a page is processed and how you can tap into them. Event handling as well. We'll look at how to handle events like page load and page init, as well as server-side control events like click events for button controls. And then we'll finish up by looking at some special directories that are defined in ASP.NET for things like placing code and deployed assemblies, as well as a discussion of the shadow copying mechanism, which makes it possible to deploy new binaries in your websites without having to shut down the web server. So that's going to be our goal. And we'll start off, as I mentioned, with a discussion of the general architecture and move on from there. So we'll start here with a look at how ASP.NET pages are processed and how you're going to work with them. So in general, ASP.NET pages, every ASPX page that you create is going to be parsed into a class definition, as you see right here. So it's going to be parsed into a class definition, and that class is then going to be compiled into an assembly. So a standard .NET assembly that contains the class definition, whose sole purpose it is to process requests destined for that endpoint. Now, this assembly is going to be loaded into the worker process, w3wp.exe, in the cases of IIS 6 and 7, and it will then, the class and the assembly will then be created and requested to process the request when it is dispatched. So these classes are created on demand, and this happens for every ASPX file. So it's an important thing to get into your head as you begin working with ASP.NET, that every time you write an ASPX file, you are fundamentally writing a class definition. And we'll look at how we can actually influence that class definition. So in general, what you want to think about as you're building ASP.NET applications is that you are fundamentally just integrating with an existing class framework by building additional classes, extending existing base classes, and controlling the class generation from the ASPX files. Now, to show you this in action, let's go ahead and go to a demo here. And what I thought I would do to start is create a very simple page and host it in IIS, and then just take a look at the class that is actually created for us by ASP.NET. So I'm running server 2008 here, which means it's running IIS 7. And I'm going to go into the default website on this machine, which is an inetpub www root. And I'm just going to create a new file. Let's create a new text file here. And I'm not going to be using Visual Studio for the moment because I just want to keep things very clear and without any clutter. So let's just create a new file called hello.aspx. And we'll go ahead and edit that file just with a notepad editor. And let's type in, again, just a very simple web page here, maybe just an H1 element that says hello ASP.NET. And then we're going to run this thing. So this should be accessible now in the browser. If we go to localhost and then hello.aspx. Okay, so that's going to map us onto the virtual directory that contains this file. And let's go ahead and hit it. Okay, so there's our hello ASP.NET page. Now, what I want to show you is how ASP.NET processed the request, because at first glance, it sort of seems like it's doing nothing more than serving up the HTML content, just like IIS might if you had a flat HTML file. But what I want to show you is that every time an ASPX file is requested, it does go through this class creation mechanism. And the first time it's requested, it goes through the parsing of the file and the source code generation for that class. Now, we can easily find this out. Let me just add a couple of things to this page here. The first thing I'm going to do is add a page directive, which you almost always have in your ASP.NET files. And this lets us influence the page class generation. So let's start by specifying a language for the class that's going to be created. And I'm also going to do one more thing, which is set debug equal to true. And what this will do, in addition to setting up a debug build, is will cause the source code files to stay on disk after the page has been accessed. And that's what's going to be useful for us, so we can actually see the page's class definitions on disk. And then finally, let's do something down here. Let's say I was loaded from in a nice little H3 element. And in here, I'm going to put use some script. I'm just going to use some server-side script. And I'm going to use the evaluation syntax, %equals. And I'm going to say get type. I know that I'm in a C# or a .NET class definition at this point, so I can retrieve my type definition. And once you have the type, you can actually access the assembly from which that type was loaded. And the assembly has a public property on it called location, which will be interesting for us because that will actually show us where this assembly was physically loaded from. And what I want to do is go open up that directory and take a look at what was generated. So let's try refreshing the page again here. And notice I now see that the assembly was loaded from here. In fact, you can see the actual assembly name is right there, appweb blah 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 .dll. So what I'm going to do is go open up this directory right here. Let's go ahead and open that up by doing start run, pasting in the definition or the directory location. And here's my directory. So it contains the residue from the compilation process, which in this case, because I chose debug equals true, includes a couple of source code files. Let's take a look at this first one here just by setting it to a notepad editor. And that is in fact the one I wanted to show you. So what we have here is the actual class definition that was used to service that request. So it didn't actually just take the straight HTML to service the request. It compiled this page here into a class definition. And let's inspect a little further. So it created a new namespace, just an ASP namespace. It put some using directives in. And if we scroll down, we see the actual definition of the class, which in this case is the name of the file with the dot replaced with an underscore. So that's how ASP.NET generates class definitions. It will also include directory structures as part of that naming scheme, as you'll see later. And it derives from a base class called system.web.ui.page. So this is the standard base class from which all ASPX files by default are derived. Now let's go poking around in this class just a little bit to see how it ultimately rendered this response, right? It was able to render this H1 element as well as this H3, which had some dynamically generated content embedded in it. So if we scroll down a bit, you'll notice eventually we find a function that includes some strings here that were written out directly. So this is a function that is called as part of constructing a tree that's going to actually render the response. And inside of here you'll notice that string, which is the beginning of the page that I wrote, including the H1 and the first part of the H3 prefix. And then it has some dynamic code injection. And notice it's got a link back to my which line that code came from on the original page. And this is what I typed in. That was my evaluation syntax, get type, assembly location. And that is simply written back to the response object, essentially. And then down here we have the completion of our HTML, which is just the rest of the static content of the page. So you can see how this file was processed and parsed into a class definition, so that when that class was created and requested to process the request, it sent back this static content as well as this dynamically evaluated expression as part of the response. So that's sort of the fundamental mechanism of ASP.NET. That's how requests are processed and how pages end up being created to service requests in ASP.NET. Now, depending on which operating system you end up hosting your website on with ASP.NET content, the integration with IIS is going to be slightly different. So what I thought I would do is start by looking at the IIS 6 integration and how ASP.NET ties into that platform. IIS 6 is what you're going to be using if you deploy to Windows Server 2003. And there are a lot of ISVs that use that as a hosting environment out there today. So the way it works in IIS 6, let me go ahead and bring up an instance of Windows Server 2003 here, and I can show you how it ties in. If you go bring up Internet Information Services Manager from the Administrative Tools list, you can see the integration if you just go to the properties of a website or an application within the website. And if I bring up the properties, you'll notice under the home directory, we can take a look at the script map, which you can see via the configuration setting. And this is sort of the standard extensibility point of IIS. It has been the standard extensibility point since its inception. In the past, people often ended up writing their own ISAPI extensions to build dynamic content. One of the things that ASP did when it was introduced, classic ASP, was sort of remove the need to build your own custom ISAPI extensions. You could simply write an ASP file and have the dynamic content parsed generically for you. And in fact, you can see that there is an ASP ISAPI extension installed here. That is how requests are dispatched onto the ASP runtime. So ASP.NET is not very different from that. It's it's very different in the sense in how it actually services requests from traditional ASP, but it is integrated into IIS 6 in much the same way. So we can see just below the ASP extension, I have an ASPX extension. In fact, all of these extensions that end with an X are associated with ASP.NET. So the ASPX extension, notice, is associated with a version 2 runtime of ASP.NET ISAPI.dll. So that's an unmanaged DLL that is sitting there, and that's going to sort of bootstrap the ASP.NET request processing for requests that are dispatched onto ASPX endpoints. So that's the association. It just needs to be in place. And in IIS 6 and 7 for that matter, both the ISAPI extensions as well as the ASP.NET runtime are going to be hosted in the same worker process, which by default is W3WP. But that's the association. If you ever find that you have a problem with your ASP.NET associations, maybe you, for some reason, ASP.NET was not installed at the same time as IIS, or it was installed before IIS was installed, just bring up a Visual Studio command prompt, which will have the right path set up for you, and run ASP.NET reg IIS. And you want to run it with a -i. There are a lot of options here, but a -i will install the script map settings into IIS for you. So that's a good way to remedy it if you ever find that your IIS script map entries have, for some reason, disappeared on you. If your deployment platform is going to be Server 2008, or if you're doing development under Vista, both of these use IIS 7 as their Internet Information Services implementation. And IIS 7 is a pretty dramatic change from IIS 6 with respect to ASP.NET integration, primarily because ASP.NET becomes a first-class citizen in the environment, whereas in the past it was always an add-on. You always had to go through IIS before you could actually get to ASP.NET's worker process and all of its handlers. So what they did in IIS 7 was they raised ASP.NET to the same level as the ISAPI modules and extensions that are available in traditional IIS, so that it's no longer necessary to implement an ISAPI handler if you want to do top-level filtering. You can actually use ASP.NET's filtering mechanism, which is the module. So anyway, if you want to see how ASP.NET pages are dispatched to inside of IIS 7, you just go to the handler mappings of your site or your application, and you can very easily identify the ASPX endpoint and the handler that's set up to process it. So let's go take a look at Server 2008 running IIS 7. Here's the sample we were just looking at. So what I'm going to do is bring up Internet Information Services through the Administrative Tools menu. The default one here is going to be IIS 7, which is what we want. And let's go ahead and drill into our server and take a look at the default website. And notice there are settings for both ASP.NET and IIS here. But what you'll notice is if I go to the handler mappings for my default website in IIS, not only do I have all of the traditional integrated ISAPI extensions like ASP, but I also have ASPX extensions here. But notice it's no longer the ASPX extension. Notice that it's no longer listed as a DLL. It's not an unmanaged DLL like we saw before, the ASP.NET ISAPI DLL, but instead it's actually the class that's going to be used to parse those pages and then create the class and service the requests. So ASP.NET becomes a top-level entity within IIS as a version 7, and this association is a direct association for a request coming into an ASPX file to the class that's responsible for parsing the ASPX file, generating the class definition, and dispatching the request onto that class. Now that we've seen how ASP.NET pages are integrated with IIS and how those requests are dispatched onto ASPX endpoints, let's go back and revisit dynamic content at ASP.NET. I showed you a small example of dynamic content when I printed out the directory in which the classes were defined and compiled. But I want to point out that ASP.NET inherits a lot of the dynamic content syntax that was available in traditional ASP, in classic ASP. Now, I like to start with this slide just so people coming from an ASP background recognize the same set of features, but I do want to caution you that you really want to move away from this programming style in ASP.NET. That is the interspersed script notation, which is often a cause for problems when you are trying to build a website that is long-lived and robust and testable, among other things. So while this syntax is still supported, we're going to move towards other techniques which are more, are easier to maintain and work with. Anyway, so what I want to show you on this page was the types of dynamic content that you can incorporate into a page. So first of all, we have the interspersed script notation that you see down here. So this is just a way of dropping code into your page. Now, unlike traditional ASP, this is whatever language you have specified up here. It's not going to be VB script or JavaScript necessarily. And then we also have the evaluation syntax, which is just a shortcut for saying response.write, just like I have down here, within a server-side script block. And then you can also include server-side script like you always have been able to in ASP, just as a delineated script block with a run at server attribute on it. And that will take this code and dump it into the class definition. So what I thought I would do is go back to our sample that we were working on in Server 2008 here and augment it with some of these additional dynamic content techniques. So I have the sample code from the slide on the bottom right down here. So I'm just going to copy in the dynamic content in the server-side script block that I had there. And I'm also going to try to make my HTML a little more proper by putting in a head and a body element and a XML namespace declaration. And finally, let's put the closing tag in for the body and all of this markup as well. Okay, so after we print out the assembly, which I'm going to leave in because I want to still find this page, I'm going to put in this interspersed content as we saw, which is going to make a call to this local function up here, getDisplayItem, to print out a particular item number as we iterate from 0 to item count, which has been defined as 10 up here in the server-side script. And then just to show you the alternate syntax, we're going to do response.write to print out the total number of items by doing a toString on the item count variable that is declared up above. So kind of using all the different types of dynamic content injection that you might encounter in an ASP.NET page. So let's go ahead and run this page now. And we should see that dynamic content popping up, and we should also still see the reference to the directory where this page was generated. And I want to do one more poke in that directory to show you what's going on. So here's the generated content. 0 through 9 are the items, total number, all that was dynamically generated. And let's go ahead and take a look at this directory again so we can see the files in there. And I'm going to open up this C# file, which is the larger of the two, so I know it's the one that contains the class definition, and scroll down. And what I want you to notice are the ways that the various pieces of server-side code were injected into the class definition. So first of all, let's go locate this chunk of code right here, right? The server-side script block. Where does that code get placed in the generated class definition? So we scroll down to the actual class definition right here, and if we take a look, you'll notice right here that those few lines of code, these lines right here, were dropped directly into the class definition. Okay, that's an important distinction to keep in mind if you end up using the server-side script technique. So that code is dropped into the class definition directly. So what that means is you can only place things into a server-side script block that would make sense if they were put directly into a class definition. So we couldn't have directly executable code, for example. If I tried to go in here and say response.write hi, right, that would be invalid. You couldn't do something like that because you can't put that directly into a class definition because that's executable code. It needs to be within a function. So keep that in mind. And then this code down here, we saw where that was, but let's go look for this code as well, the for int I equals 0 to item count. If we scroll down a little bit, we should see that code. There it is. So it was dropped into this function that's going to basically be writing back to the response object on the fly. So it's going to take this whole collection of this block of code here and iterate 10 times as it prints out the dynamic call to getDisplayItem. So all of this code, the code that was actually dropped into the main part of your page using the interspersed script notation and the evaluation syntax, is going to be dropped directly into a function definition within your class. So that is a reasonable place to place code, obviously, but there are certain things you cannot do. For example, I could not define a function here because you can't create nested function definitions in C# or VB. But you could do variable declarations. They would just end up being local variable declarations. So important thing to note, if you end up using these various server-side code notations, again, I'm going to encourage you to steer away from this type of programming, and just because there are better ways of doing it in ASP.NET. But it is important to be aware of how these things actually manifest themselves in the resulting pages. I mentioned that you should try to, in general, avoid the interspersed script that tends to clutter pages and ends up creating code that is difficult to maintain and understand over time. But I haven't shown you how to avoid it yet. So let's move now towards the preferred model of dynamic content in ASP.NET pages. And that model comes from the server-side controls in ASP.NET. So the way these work is any control on your page that is marked with the run@= server attribute. And this can literally be any HTML element if you want. You can turn anything you want to in a server-side control. Or it could be one of the specially defined server-side web controls that ASP.NET provides for you. And what this will do is it will give you a server-side member variable of a particular type associated with that control that is going to be added to your class definition. So that class that we saw that was automatically generated from the ASPX file is going to be augmented with a new member variable of a specific type that you can then programmatically access on the server instead of having to intersperse script notation to generate dynamic content. You can actually programmatically manipulate the objects that are added to your class definition. And this gives you a much cleaner way of generating content dynamically and having it rendered to the client without having to clutter the markup on your page. And there is one other thing to be aware of, and we'll talk more about this later, which is the fact that the state for these server-side controls is implicitly maintained across post requests back to the same page. So we'll discuss that more later, but it's important to keep in mind as we start working with these features. Okay, so we're going to go back and revisit our page, but this time what we're going to do is take out some of that server-side script that we had and try to replace it with server-side controls that we interacted with dynamically in our actual class. So I'll follow this example that you see on the slide here in our sample application. Let's go ahead and switch back to that. And I have the code from the slide down here on the right, and I'm going to inject that into our page. So let me change a couple of things here. First of all, let's get rid of this dynamically generated list. Okay, so this list right here, which had all of the interspersed script notation, I'm going to replace that with a server-side control definition called a bulleted list. Okay, so there's my bulleted list, like so. And I'm doing using a technique that's fairly common in ASP.NET, which is to populate the server-side control with some sample content, even though this content is not ever actually going to be displayed because I'm going to replace it on the server. It's not a bad idea to include some sample content so that when someone's looking at this page through a designer, they see a representation of what it will look like eventually. Okay, so what I've done is I'm using an ASP.NET server-side control called a bulleted list, which in fact will render an unordered list, which is what I just replaced. And I now need to add the server-side code that's going to populate it. And what I'm going to do is actually override a virtual function called onload that I inherit from the page base class. And we'll come back and show you where that comes from in more detail in a few slides. And what I'm going to do is take advantage of the fact that this control, the bulleted list, was added as a member variable to my class definition, and the identifier is going to be the same as the ID that I specified on the markup element. So I can refer to that control just by specifying or using the underscore display list variable here. And I happen to know this list. You could look up the definition for bulleted list to find out all of the properties that it exposed, but I know that it exposes an items property which contains all of the default items that will have been injected there, and I will clear those out first, and then I'm going to iterate across my collection up here, the item count, just like I did before. And instead of printing directly to the response, I'm going to construct a new instance of a list item class, give it the content of the calling this getDisplayItem function, and this will result in an unordered list that contains all these items dynamically injected as we did before. So let's try running that page now. which should look fundamentally the same, although we've changed the implementation a bit. Of course, there's one exception here. Anytime you're using server-side controls in ASP.NET, they typically need to be in a form element with the run@server attribute set on it, which you'll find quickly if you forget, as we did here. All right, let's try that one more time. Okay, so there's my items rendered just like before. And again, let's go take a brief look at the class definition so we can sort of see how that changed with the addition of the server-side control. So I'm going to scroll down to the class definition again. Here it is. And you'll notice right at the very top there, the server-side control display list was added as a protected member variable to my class definition of type bulleted list in the System Web UI Web Controls namespace. And as I interacted with that member variable down here, that's what it ended up referring to. Okay, so server-side controls are turned into member variables on the class definition, and I could very easily have gone in here and replaced these other server-side elements with server-side controls instead of using the markup as we did before. But I'll leave it at that for now. Now in the previous example that I just showed you, we ended up interacting with the control at a pretty low level, that bulleted list control. We actually went in and called clear items. Let's just review that quickly. So we called clear on the items collection right here, and then we iterated across our collection of items and manually called add to inject a new list item for each one. It turns out this is a very common thing to do. Not this specific code, but the concept of taking a collection of items and displaying them in a control that is capable of displaying multiple items together. So instead of doing this by hand every time, ASP.NET supports a data binding model, which is going to be what you'll tend to use for taking collections of items and binding them to controls like we did. So the way this works is, first of all, I'll need to come up with a a collection of some items. So instead of calling that function over and over, I'm going to keep it simple and actually just define a string array with all the items I want to show. Now this could be any enumerable collection. So it could be the results of a database query. It could be a data table or a data set in memory. It could be a strongly typed generic list class, whatever you want, as long as it implements the IEnumerable interface. And the data binding mechanism looks like this. You set the data source property on the control equal to the collection of items you want it to bind to, and then you explicitly call data bind. So this is a much more common technique for populating a control's contents when you want it to display contents from a collection like so. So let's go ahead and modify our sample here to use the data binding model. So again, I have the slide example in the lower right hand corner here, and I'm going to go up to my page and drop in that member variable definition that contains the 10 items of data that I want to bind to. Okay, and let's go down to our load handler now, and instead of doing all this manual code injection or manual binding ourselves, let's bind the control directly ourselves. So I'm going to say display list dot data source is going to be equal to the display item data, so that's the array up above, and then we just call display list dot data bind, and that will cause it to walk across the collection and inject each item respectively into its internal collection. So down here, these three items will be replaced with whatever dynamic binding occurs at this point right here. So let's go ahead and try running that, see if we get pretty much the same results, which is what we expect. And indeed we do, although my items are numbered 1 through 10 now instead of 0 through 9, but that's an artifact of my array declaration. Okay, so usually you won't end up interacting with the controls at that low a level because you have this data binding mechanism in place to take collections of data and bind them to the controls on your behalf. to complete our story of ASP.NET server-side controls and binding, we need to go over the declarative data binding model as well. So we started off with the interspersed script notation. We talked about how you can remove a lot of the script by using server-side controls, and we talked about how you can remove a lot of your code in your server-side pages by using data binding, so we didn't have to interact with the controls in such a fine-grained way. So version 2.0 of ASP.NET actually introduced yet another enhancement to this server-side data binding model called declarative data binding. And we'll spend much more time looking at the details of this in a later module, but I just wanted to preview it for you. So the idea behind declarative data binding is that instead of manually setting the data source and calling data bind yourself, you hand it off to another control. And in this particular case, we're going to be using the object data source control. Now there are several different data source controls in ASP.NET. There's the SQL data source, the XML data source, etc. The object data source is the one that lets you point to a class definition and say, go get your data from here. And the way you point to it is you give it the name of the class that you want to use right here, and then you tell it the method you want it to use to retrieve data. And it will then go invoke that method on this class to return the list of items. Now what I'm doing in my example here is I'm going to return a list that looks very similar to our previous lists just by using the yield return operator that builds up an IEnumerable implementation for us and iterating across the item count. I also will keep a static count of items here so that we can refer to that. So let's go ahead and try this out. Let me just point out one of the motivations behind this, which is the class. Now your page will not have to have any code in it whatsoever. You have now isolated the data access code into a separate class, which you can include as part of your project, or you can bring it in as a separate assembly, whichever makes sense for you. So we've really separated the concerns of the page to be exclusively about presentation and isolated the data access into a secondary class on our site. So let's go ahead and try this out. So back here is my Hello ASPX page. What I'm going to do at this point is save this as a new file. So we keep that older one as it was, so we can refer to it later if we want to. And I'm going to start by getting rid of all of our server-side script code, because that's now going to be handled for us by this declarative data source. And now let's go and put the server-side, the actual class definition in place. Now I'm going to have to preview a directory for you. It's one of the special directories in ASP.NET called app_code. This is a directory that is specially named where if you place any source code files into this directory, they will be implicitly compiled as part of the request processing in ASP.NET, and you can refer to those classes in any of your pages. So I'm just going to go create a new source code file here called items data source.cs, and let's go ahead and edit that. And I have the class definition I'd like to use right here, basically from the slide, but I've included a couple of namespaces we need to get it running. And I've also included a public static property to access the item count value, so we can refer to that. Okay, let's go ahead and get this wired up. So let me grab also the object data source declaration, place that into our page here next to the bulleted list, and then we need to wire it up to the bulleted list by setting the data source ID equal to under items data source, like so. So those two are now associated, and when this control needs the data to present, it will go query this object data source, which in turn will go query this class's getItems method. The one last thing I need to change is the retrieval of the static items count down here, which is no longer going to be local. It's going to be part of this class definition. So I'm going to access it through this item count property, which we see right here, and call toString on that. Okay, so notice my code is gone. I've placed my code into this secondary source code file dropped within the app code directory, and I'm relying on the declarative data binding model to supply the supply the items collection for this bulleted list. So let's try hitting this page again, remembering that it's hello2.aspx and not hello. And fortunately, it looks pretty much the same, which is a good sign. So this is all being bound using declarative data binding now, and that's retrieved via that class's static property definition. Now we've looked at several techniques that ASP.NET provides to reduce the amount of code necessary in your page to actually present dynamic content. And data binding is going to be a big step in that direction. However, you still are going to end up having code in many of your pages, whether it's just for event handlers that you're doing processing on the server with, or some sort of user interface interaction with the client. And if you want to remove that code from the actual ASPX page and leave the ASPX page to be only markup, and then put the code in a completely separate file and in a separate class definition, this is where you can bring code behind into the picture. So this is a technique for separation of code and markup that ASP.NET has had in place since its inception. And there are two techniques. There are two implementations of it, shall we say. One is the original implementation, which is what came out with ASP.NET 1 and 1.1. And the other one is the 2.0 version, which is a slight different variation on it, which uses the partial class mechanism. So what I'd like to do is start by showing you the 1.1 version of Code Behind, which, as you'll see, is very similar to the 2.0 version. But even though you may not use this style of Code Behind directly, there's a good chance you'll encounter it in your ASP.NET development. So it's good to be aware of how it works and what the various attributes mean. And then we'll go ahead and take a look at the 2.0 version and see how that differs and how to use both. So what I thought I would do to show you Code Behind is go back to our samples here and go to the original page that we were working on, the hello.aspx page. And I'm going to just create a copy of that page, and let's call it hello CB for Code Behind. And I'm going to also create an associated Code Behind file. And I'm going to use the naming convention that is very standard in ASP.NET to call the Code Behind file the same thing as the page, but with a source code extension, so .cs for C# in this case. Okay, so let's go open these two files up now. Again, just using Notepad to keep things really simple here. We'll come back and use Visual Studio in a little bit. And here's the Code Behind file. Now I'm going to bring in a couple of namespaces into the Code Behind file. And what I want to do is take all of this code that was in our ASPX file and cut it out and place it in the Code Behind. That's really the motivation here, right? You want to have a completely separate file that contains all of your code definition, your code for the page. And now we're left with just this page here. Of course, you can't just leave it in the file like this because that's not going to compile. So we encapsulate this in a class definition. I'm going to start by putting it in a namespace, and then we'll define a class that surrounds it. So for the class, let's do this. Public class hello CB base maybe. And what we're going to do is derive from the page base class. So the relationship between this class and the class that is going to be generated by ASP.NET is that we're going to be the base class for the generated class created from this file. Okay? So here's our class definition. Now that's almost ready to go. The one thing we're going to have trouble with at this point is our reference to the display list. Because this is a member variable that was implicitly added to this class definition when it was automatically parsed and compiled by ASP.NET. But we're not going to have access to it here because we're serving as the base class. So the technique in version 1 of ASP.NET to resolve these server-side variable references, this guy right here, is to go into your class definition and add protected member variable declarations of the appropriate type. So this is a bulleted list control, and there's the name. And when this file is now compiled over here, it will notice that the base class already has a protected member variable declaration whose identifier is equal to or is identical to the identifier for this server-side control. And as long as these types match, the bulleted list matches this type here, it will happily use the protected member variable declaration that we defined in the base class. And that will associate it with this guy, and now this will resolve properly to this particular control. Okay, so that's a code behind class ready to go. Now to wire it up, to actually get it compiled and wired up to this class, we need to go to our ASPX file and tell it which class it's going to inherit from by using the inherits keyword in the page directive. And I'm going to say ps.hello cb base, I believe is what I called it. CB base, yeah. Okay, so there's the base class. And if I wanted to, I could simply compile this file and put it in an assembly in the bin directory if I preferred. Or I could put it in the app code directory. Or the other option in the 1.1 model is to use this source attribute. And the source attribute lets you specify an additional file that you would like to be compiled when this page is requested. Okay, so there we go. There's my ASPX page. Here's my code behind. And now I've successfully extracted all of the code into a separate class definition from which this page is now going to inherit. And that's the code behind model in version 1.1, which still works in 2.2. So you may run across it. Local host, and we're going to do hello cb.aspx. And getting a compilation error, which we'll try to resolve here real quick. So this item count, oh, this guy is missing now. Item count is missing. And the problem is, this is actually an interesting problem, the item count is now a private variable, implicitly private, inside of my base class definition. And because we're dealing with inheritance, we need to make this, at the very least, protected so it is accessible to this page when it derives from this base class. So let's change that and go ahead and try refreshing the page again. There we go. So everything works as before, but now our page is devoid of code. And of course, we could get rid of these final last pieces if we spent the effort. And I have this completely separate class definition sitting here that is acting as the base class for this page. So this is a very common way to put pages together in ASP.NET to create a code behind class that is going to act as the base class for the other page. And now we'll take a look at the version 2 implementation of code behind. We've seen how code behind works in version 1 of ASP.NET in 1.1. Let's go ahead and look at the change that was made in version 2. Now, this is now the preferred model for code behind. The 1.1 model is still supported. So if you have pages that are built using the 1.1 code behind model, they will compile successfully in version 2 and 3.5. But you definitely want to prefer the version 2 model. This is what Visual Studio will push you toward and what you should strive to use. So here's the change. In fact, let's just go jump right into our code and transition our pages into the 2.0 model since we are running ASP.NET version 2. So we'll start here and change a couple things. One is, instead of using the source attribute, which is what we used in the 1.1 version to automatically compile a file, I'm going to use the code file attribute. And that's really the only change we have to make here. Code file is a 2.0 specific attribute that says use this code behind file and compile it as the base class to me. But as you do the compilation, I would like you to automatically generate a sibling partial class to the class that's there. And the key thing that that's going to do is it's going to eliminate the need to add these member variable declarations. So you no longer have to declare member variables for all of these server-side controls in your page. They are going to be declared implicitly for you and added to your class definition. Now, they're not going to be physically added to the class. They're actually going to be added to another class, but the class is going to be merged with yours, which you need to indicate by specifying the partial keyword on your class definition. So those are the only two changes. Mark your class as partial. Eliminate any of your protected member variable declarations, and in general, you just don't have to add them anymore. They will be implicitly added to the sibling partial class that's generated for you. And just go about your business and use the server-side control variables as if they were members of your class definition. So that's pretty much it. Let's go ahead and try refreshing the page just to make sure that worked. It did, so everything's fine. Now let's go to that directory, and what I want to do is point out the sibling partial class that was generated on your behalf, if we can find it here. So let's take a look at the source code files. Let's sort by type. Scroll down to the source code files here and look for the more recent one that is large. So that's probably this one right here. Let's try opening that one up. Okay, so what do we have here? Notice we have in this file a partial class definition. So this was automatically generated by ASP.NET, and you'll notice that it looks very similar. It is identical in declaration to our original class. Here's our partial class definition that we created, and here's the partial class definition that ASP.NET created. So notice they look the same. And that's intentional. ASP.NET is simply augmenting our class definition. Partial is just a way of spreading a class definition across multiple files. So when this gets compiled, these two definitions are going to be merged into a single class definition. And it's a very common technique used in a lot of development environments and the Microsoft platform today for conjoining machine-generated code with developer code. And here's the key thing that was added for us is the bulleted list declaration. So it automatically goes through and detects all of the server-side controls on your page and adds protected member variable declarations for each of those controls. There are also a couple of strongly typed property accessors that are added, as you'll see later, one for profile and one for the application instance. Okay, so that's the main class. And then if you scroll down here, this is the class that is generated automatically for the page, like we saw before. And the only difference you'll see now is in this class definition, it no longer inherits from page, but rather it's going to inherit from our class, which has now been merged with the partial class definition that has the member variable declarations. Otherwise, it's all the same thing, right? So this all turns into the same thing in the end. We just added a new base class that is being merged with this sibling partial base class for the variable declarations. Okay, so that's the 2.0 code behind model. Here's a depiction of the class generation just to give you a quick rundown of how that worked again. So this right here is the class that you create, and you go ahead and assume the presence of member variables based on your page definition and the controls there. And ASP.NET will take care to generate the class definition for the ASPX file, as well as the sibling partial class that's going to be merged with your class that will include all of the server-side control variable declarations. Okay, so we have our code behind in place now. You have the ability to separate an entire class definition to a different file and have that be the base class for your pages. Let's dig a little bit deeper into other things you can do inside of your page class definition. Now, if we look at the page that we wrote earlier, let me just bring that up quickly here. Recall that I overrode this virtual function onLoad in the base class. This is an example of one of the events that takes place during the request processing of the page. And it turns out there are quite a few events you can tap into if you want to. OnLoad is by far the most common. This is the one you'll tap into to do things like data binding if you're doing explicit data binding, initializing values and controls, modifying values, etc. So it's a very common one to add a handler for. But it turns out it's just one of many events that take place in the request processing lifecycle. So what I have here is a description of all the various events that you'll encounter when a request comes into your page. So what happens when a request comes into an ASPX file is the class that is constructed from the page definite from the ASPX file is created. You have a new instance of your class created. Its constructor is going to be called. That will always happen first. And then it's going to launch this lifecycle sequence, starting in the upper left here and going all the way down to unload. Now, the one I just showed you was this load event. That's again probably the most common one that you'll end up adding a handler for, and we'll talk about various other ways of subscribing to these events, by the way, in a few moments. But let me point out some other common ones that you may consider bringing into the picture. One is the init event. Now, this is a common one because it's going to be called very early on in the life cycle, but late enough so that all of the controls and such have been constructed in the control tree. So you could do things like inspect the control tree and take a look at it. Other events that are useful include the load complete event over here. Load complete happens immediately after all of the server-side events have already fired on the server. So if you have a button, its click event will have fired by the time you get to load complete. This is a new event in version 2, by the way. Notice those are all marked with the 2.0 notation in the diagram. In the past, the best place to add code that needed to be fired after the server-side events had fired was the pre-render event, which you see down here. And that can also be a useful event, but in general, I would recommend you go with the load complete event if you're looking for a place that occurs immediately after the server-side event have fired. Pre-render is sort of a backstop. If you need to do something just before rendering actually takes place and the response is sent back to the client, that's when you might consider using pre-render. There's also a preload event in this release, and preload is just called before load, obviously. It can be useful if you want to do something prior to all of your load logic being executed, so something prior to your data binding and that type of thing. There's also a pre-init event. This will become important later when we start looking at master pages and themes, because that's the only event in which you can actually manipulate master pages and themes. There's also an init complete event. There's save state complete. And then finally, at the very end, we have the render function, which is when the response is actually sent back to the client, or rendered and then sent back. And once it's sent back, you have the unload event taking place. So keep this sequence in mind. As you're building logic into your page, be aware of the order in which these events fire so that you don't do something that might be undone later. For example, if you try to set some state in a control in the init event, you're pretty much guaranteed that's going to be overwritten by the time you get to load with any values that are retrieved from the post body or from the declarative initialization on the page. So things to keep in mind as you work with the event lifecycle in ASP.NET. Let's talk now a bit about how to wire up events to your page class. So we looked at one way in the example I showed you earlier of wiring up the load event by overriding a virtual function. And this is a technique you can use for all of the events that are defined in the page lifecycle. So there's a corresponding virtual function, just like you see here, for each of those events. And the naming is simply the prefix on with the actual event. So there's on init, there's on pre-render, there's on load, there's on load complete, etc. This is so one technique you can use. If you're working in Visual Studio, however, that's not the standard technique you'll see. The standard technique is the one you see on the bottom down here. And this one is kind of less obvious, but all you need to do is create a function named page underscore and then the name of the event you want to add a handler for. And what happens when you do this is it will ASP.NET will implicitly subscribe that function via a delegate to the corresponding event in the page lifecycle. So you don't have to wire it up yourself. You don't have to override a virtual function. All you have to do is write a function that is named that. And this is a feature called Auto Event Wireup that is enabled by default, and it is the preferred model in Visual Studio 2008 as well as 2005. There are other techniques, by the way, just so you know, in case you run across them. You can also do this. you can also always access the event directly as members on your page class, because these are all simply .NET events defined on the system.web.ui.page base class. So you can always use the plus equals syntax to subscribe a new delegate, and you don't even have to allocate the delegate as a version 2. It'll just implicitly create it for you. So you can create your own functions in that manner if you like. So let's go ahead and try this. I'm going to go back to our demo here, and let's try adding another event handler. And just to keep it simple, let me try using that auto event wireup technique that I described. In fact, if you ever want to control that, you want to control the auto event wireup, you can specify here auto event wireup. And again, it defaults to true, so this is not strictly necessary. But if you wanted to disable it, you could turn it off by default by setting it to false. That was the default in 2003, by the way. It always generated the auto event wireup and set it to false because they preferred other techniques. So once that is set to true, and knowing that it's set to true, we can create a protected function. It must have the right signature. Void, call it page underscore, and let's do load complete. So the one that comes right after the load event. And the signature must be the standard event handler signature, passing an object reference, which is the sender, and an event args parameter, which are the parameters coming in from the sender. And inside of here, we could do something just like write to the response, just to get something out there. Page load complete called. Okay, so that's an example of wiring up an event handler using the auto event wire up mechanism and having it implicitly wired up to the corresponding event. So let's try launching that page, localhost hellocb.aspx. It's the right file. And notice at the top our page load complete event did in fact fire, and we were able to trap it. So you can use that technique to subscribe to any of the events just by prefixing the function name with the name capital P page. So in case you were wondering how that auto event wire up mechanism works, I was always curious, so I eventually dug in and went and found out where they actually do the wire up. And it turns out the story is this. There's basically just a hash table they keep in their code with a list of strings, and each of these strings is compared at runtime to see if the corresponding class has a method that matches one of these predefined values. So there's no algorithm going on here. It doesn't actually try to detect an event in the class definition and prefix it with a page underscore. It's really just a hardwired set of strings that are automatically looked for when the auto event wire up property is set to true. So anytime you define a function named page underscore preinit, ASP.NET will automatically subscribe that function to the preinit event. And this is also contingent, by the way, on that function having the correct signature. So it must have the void return value and accept an object and an event args pair of parameters. But these are all the functions, in case you're curious, that will automatically be subscribed to events along with the associated event on the right here that the function will be subscribed to. The other events that you'll often end up adding handlers for are events that are issued by controls on your page. So for example, if you have a button control on your page, you almost always will add a handler for the click event of the button. So you know when the user actually clicked it, and you need to initiate the action in response to it. As of Visual Studio 2005 and 2008, the preferred model for subscription is to use this declarative model, where you simply go to your server-side control declaration and use the on prefix followed by the event name, and then give it the name of the function you want it to wire up to, and that function must have the correct signature, just like we showed earlier. And this will be wired up as the handler for that server-side event. So that's probably the simplest way to do it, and that is the way that Visual Studio 2005 and 2008 both prefer to do it. The other way you could do this, if you wanted to, was in your server-side class, your page class, you could always use the standard delegate or event subscription notation by using plus equals in C#. So let's go ahead and try this out just to give you an idea. I'm going to go to my page, or the ASPX file we've been working on here, and down at the bottom let's place a button, and while we're there, let's go ahead and place a label as well, so I can print something out in response to it and give it an ID equal to message label and run at equals server. Okay, so there's my label with the corresponding button, and what I've done is I've declaratively wired this button up with the onClick event handler, again the preferred model in Visual Studio these days. And so all I need to do is to go into my server-side code and actually write the body for that function, which I have a shell of right here. So I'll drop that in. There's my server-side function that will be called in response to that button being clicked. And let's just go ahead and grab the label when this is clicked and say label.text is equal to hi there from button click. Okay, so that's the idea. Again, this is the standard model for subscribing to events of server-side controls. And once you click on the button, we processed the post on the server and responded with a population of that label control. One of the other features they added in the 2.0 release of ASP.NET was a suite of specially defined directories. Now, we've already mentioned one of these, the app code directory, which is probably the most common one you'll end up using. And the app code directory is a place to put source code files, which you can will be automatically compiled as part of the request processing sequence. So that's one. There are actually several others, though, that are good to be aware of, and we're going to cover these in more detail in future modules, so that we'll look at how to use them effectively there. But I just want you to be aware of the names of these directories, so you don't accidentally, put one in yourself that is going to have unwanted behavior. So there's an app browsers directory, and this browsers directory is used for defining additional .browser files that can describe browser capabilities. There are a pair of resource directories that you'll see right here, app global resources and app local resources. And these are used to automatically compile resx files into your application. Again, we'll take a look at those later. There's a themes directory that's used for referencing themes in your site and defining themes. And there's also a web references directory where you can place WSDL files, WSDL files, and have your client-side proxies for web services automatically generated as part of the request processing. And then finally, I just do like to mention there's a new compiler that ships with version 2 of ASP.NET called ASP NET Compiler, which lets you compile your entire site into a binary deployment. And we'll be looking at that in much more detail when we get to our deployment discussion. So here's a brief reference of all these directories and what you can place into them. Again, I'll just quickly summarize for you. So the app browsers directory is used for .browser files. That's an XML format for describing browser capabilities. App code is for placing code files. It also supports schema files for strongly typed data sets, as well as WSDL files. You can place those here for generating the web service descriptions. You can also put those in web references. App data is a special directory, a conventional directory. It's not actually treated any differently by ASP.NET, but it's a convention for placing data files like databases or XML. These are the resources files, the themes file, the web references, and the last one I want to mention is the bin directory. And this is the location where you're going to deploy binary assemblies that you want to have accessible to all the pages in your site. And we'll take a look at using the bin directory in just a moment here. The last thing I want to touch on in ASP NET Architecture is the mechanism for shadow copying. This is an important feature if you're going to be deploying sites, updates to your sites on a running server. And the idea is this: if you're using assemblies, packaged assemblies in your application, and we'll do an example of just this in just a moment, and you're deploying them to the bin directory of your site, which is going to make them accessible to all the pages in your application. Traditionally, when you deployed binaries to a web application in, say, classic ASP, if it was, say, a COM component, you would have to shut down the server to release references to the binaries so that you could redeploy the new copy. So what they did in ASP.NET was they introduced this technique called shadow copying, which it's actually a feature of the .NET runtime, which when you're loading an assembly, instead of loading the assembly directly from the location where it's deployed, which is going to be here in the bin directory, .NET will implicitly copy that up to a obfuscated directory. So it's going to be under the temporary ASP.NET files somewhere. And it will physically copy the binary up there, and then it will reference this one instead. So it won't reference the original one. And it will also keep a timestamp on the original one. So if this one, if the original one ever changes, it will generate a new copy of the updated one and refer to that one. So the end result is you'll be able to deploy changes to your site, even if they're binary changes, in the bin directory without having to shut the site down. So let me jump to a demo here. This is what I'm going to do is go build in a little calculator component that I'm going to use in my site. And again, I'm going to stick to doing this all from Notepad and the command line, although we're going to next work through the same steps we've been through here in Visual Studio. So I have a calculator definition. It's a very simple class that has a static method on it called add, and I've intentionally put an error in my addition logic right now. And what I'm going to do is go compile this into an assembly. So here's the source code file, calc.cs. I'm going to run the C# compiler specifying a target of library and run it against calc.cs. And that's going to give me a DLL. There's my calc.dll. And let's go ahead and deploy that DLL to my directory, my website up here, which is just the root website on this machine. So I'm going to create a bin directory and deploy the calc.dll into that bin directory. So that should give me access in all of my pages to that calculator class. So to make this a little bit more interesting, let's actually build up a calculator user interface by putting in a couple of text boxes. So add, and I just placed a couple of server-side text boxes here, one called _xval and one called _yval. And I still have the button here. Let's change the button from click me to add numbers. And we'll leave the message label as it was before. And let's go to our code behind class, which I have right here, and build up the logic for processing and calling the calculator. So let's go into our click event handler, which is right here, and instead of setting the label to some random text, I'm going to get the x and y values from the text boxes that were that I just added to my page, and then we'll send the values of those into the calculator class. So I'm going to say int x is going to be equal to int.parse to grab the string of _xval.text, and int y equals int.parse of _yval.text. Okay, so I should have the two values now. I'm not going to bother with error checking to see if they worked or not. We'll just assume they're there. And let's now call ps.calc.add with x and y. And that's going to give us back the summation, and we'll just set the message label.text equal to the result of calling that and then turning it into a string. Okay, so let's make sure we got all those pieces right. So ps.calc is a static function called add, and I'm calling that with the two x and y val text boxes that I placed on my form, and I'm printing the results to this message label. All right, let's try giving that a go. So here's the main page. Let's try adding 3 and 4. Add the numbers, and notice we're off by 1. Okay, so we're in a good situation now. The server's up and running, and what I want to do now is go fix my calculator so that it no longer is off by 1. So we make the modification to the source code, we go back and recompile the assembly, and then I'm going to redeploy it. And this is where you would traditionally run into a hitch if there were a lock on that binary. But notice move and replace works fine, there's no issue. And I can go back to my website. Let's do a fresh GET request on the page. And it comes back and I add 3 and 4, and this time we get the right value. Okay, and that was all achieved because this assembly was never referred to directly. It was rather shadow copied. And the shadow copy reference is the only one that was had a lock held onto it. I thought I would finish this module by giving you a quick introduction to working with Visual Studio and ASP.NET, which we're going to be using for the rest of the modules in this ASP.NET course. So I'm going to go ahead and launch Visual Studio 2008 and just point out a few things that you want to be aware of as you start building your web applications inside of Visual Studio. And also point back to a lot of the techniques that we discussed and how they manifest themselves inside of Visual Studio. Now, there are actually 2 different ways of creating projects in Visual Studio 2008. One is to create a web project, a web application project, and the other is to create a website. And we'll talk much more about the differences between those in a later module. For right now, we're going to start with a website that is kind of the simpler of the 2. And a website is just going to create a new directory for you with ASP.NET files in it, and I'm going to just drop this into c/demos/hello vs 2008. And there are a couple things I want to note here. We're going to be given a default.aspx file initially, and notice at the very top here that it automatically uses the code behind model, the version 2 code behind model that we discussed. So there's the inherits keyword, there's the code file keyword, and the corresponding code behind file is sitting in the same directory using that same naming convention that we discussed. There's also a handler for page load that's already subscribed and ready to go. I'm going to go ahead and split the design view here so we can see both the markup as well as the designer. And as you start adding handlers and controls, let's go ahead and drop a button on here, for example, and double click on the button to add a handler. Notice it gives us the event handler in our code behind class, and our markup shows the wireup has been done using this on-click declarative event handler. So all those techniques we discussed are going to be used in much the same way within Visual Studio. You just don't have to do quite as much typing. The other thing you'll notice is if I try to add a new class definition to my project, so let's just go ahead and choose class here and leave the default of class 1. Notice I'm going to be prompted to say, hey, do you want to add this to the app code directory? Because if you want it to be compiled, that's really where it should go. And it automatically generates a new app code directory for you. Also notice if you want to add your own special directories, ASP.NET, it's got an add ASP.NET folder here, so you can add any of those specially defined directories that we were discussing. Now, the one thing that there isn't direct support for when you're working in C# in Visual Studio is adding handlers for the other page events. So if you want to add the other page events, for example, init, you still need to go through the process of defining a function that looks just like this, except you want to call it page underscore init instead of load. And that's going to work fine. Or you could always use the virtual function technique and override on init like so, and that will wire up the same event for you. So both of those techniques work fine. And here's the completion of the button handler. Let's just go ahead and finish wiring that up. So I'm going to, inside the button when it's being clicked, let's just go ahead and say label1.text equals you clicked the button. Let's try to fix those spelling errors. And the last thing I want to mention about Visual Studio is you don't even have to have IIS installed to start developing websites. Now, you would have to deploy it, But to actually develop it, they have a built-in web server to Visual Studio called the ASP.NET Development Server. So when you do a debug start without debugging or start debugging, it will actually launch this development server for you, listening over a random port. In this case, it's 1055. And that will host ASP.NET for you. So as you interact with the page, it'll behave pretty much like it would if it were deployed in a real website. So you can actually start building applications without having to worry about configuration or deployment into IIS. Although you definitely want to think about that because that's where you're ultimately going to end up placing these things. Okay, so in summary, this module we had a chance to look at several different aspects of the ASP.NET architecture. Started off with a look at its integration with IIS, both IIS 6 and 7, and how in IIS 6 it acts as sort of an add-on and it has to go through IIS before it's actually dispatched onto ASP.NET. Whereas IIS 7, it becomes a first-class citizen and you can actually make modifications to requests going into IIS directly with ASP.NET. We talked about dynamic content, how you can inject dynamic content in your pages, which is really what the main idea behind ASP.NET is for building pages that are constructed dynamically. And there are several techniques. Server-side controls are the foundation of most of these. Techniques for data binding, including declarative data binding that was introduced in version 2, can simplify the code that you have to put into your projects. For the code that you do have, we looked at using code behind and how to separate out code from the markup of your page and create a base class definition that is inherited by the main page class. We also looked at the page lifecycle, all the various events that occur each time a request is processed, starting from the pre-init event all the way down through unload and everything in between. Event handling, both for page lifecycle events as well as server-side control events. Both are preferred. The preferred model for subscription is the declarative model, which Visual Studio 2008 will use, which for controls is to use the on syntax, just an on with the name of the event, and for page lifecycle events is to use the auto event wireup with the specially named functions that are prefixed with page underscore. And finally, we touched on the several of the new special directories in ASP.NET for compiling code and resources and browser capabilities, among other things.